Okay, so let's summarize. Up until this point, we found a lot of derivatives. Derivatives of polynomials, derivatives of rationals, derivatives of products, derivatives of quotients, derivatives of trig functions, derivatives of exponentials, derivatives of logarithmic functions. So another type of function you studied in pre-calculus is the inverse trig function. What are those derivatives? So this video is going to be very short, partially because the majority of the time you should spend getting to know these derivatives and memorizing them. So the proofs will be done in class, and we'll talk about that when we are in class. For now, let's collect all our derivatives in one place. First, the derivative of arcsine of u, where u is a function of x. That derivative is 1 over the square root of 1 minus u squared times du dx. Derivative of arc cosine of u is very similar. That derivative is also involving 1 over square root of 1 minus u squared du dx, but notice it's got a negative in front of it. If you remember when we did our trig derivatives, the derivatives of all the trig functions with a co in front of them were negative, and it's the same here. The derivative of arcsecant of u is a more unusual formula that we'll talk about in class, and that derivative is 1 over absolute value of u times u squared minus 1. And the absolute value comes from the unusual way in which we define the arcsecant function and its domain and range. Notice again we have that extra du dx if the function that we have, u, is some sort of function of x, our input. Again, derivative of arc cosecant of u is negative 1 over absolute value of u times u squared minus 1 times du dx. That negative out in front comes from our co-function portion. A little bit easier formula is the derivative of arctangent of u. That derivative is 1 over 1 plus u squared du dx. And you guessed it, derivative of arc cotangent of u is negative 1 over 1 plus u squared du dx. So 6 formulas to know, 6 formulas to memorize. An example from the reading. Let's say we wanted to find the derivative of arcsine of 5x. We've got an inside function there. We've got our outside function of arcsine and our inside function of 5x. So we go to our formulas, and we do not forget the chain rule. The derivative of arcsine is 1 over square root of 1 minus the input squared. The input in this case is 5x. And the derivative of the inside function is 5. So that's why we have that extra 5 there. Simplified, we get 5 over square root of 1 minus 25x squared. Example 2, let's say we want to find the derivative of arctangent of e to the x. Hey, look at that. We've got another inside function. It's that e to the x. So we go to our formula. Derivative of arctangent of something is 1 over 1 plus that something squared. In this case, the inside function is e to the x, so our formula then becomes 1 over 1 plus e to the x squared. Oh, is that a typo? Times e to the x, where's that coming from? Oh, wait, that's the derivative of the inside function, e to the x. Oh, got it now. So we're left with e to the x over 1 plus e to the 2x, the e to the 2x coming from some nice manipulation based on our exponent rules. Our final example, the derivative of arc cosecant of 1 over x. All right, we do have an inside function here as well, so we'll need to take that under consideration. Derivative of arc cosecant is negative 1 over the absolute value of the input times the square root of the input squared minus 1. The input in this case is the 1 over x, so we plug that in. We get negative 1 over absolute value of 1 over x times the square root of 1 over x squared minus 1. And again, by the chain rule, we need to find the derivative of 1 over x, or x to the negative first power. That derivative is negative 1 over x squared. Now, just so I can show you how you might simplify the algebra, we can multiply the 1 over x squared and end up with negative 1 over absolute value of 1 over x times the square root of 1 over x squared minus 1, all times negative 1 over x squared. Find a common denominator. Inside that square root, we end up getting 1 minus x squared over x squared. The real cool thing about that is, if you remember, the absolute value of, the square root of x squared is equal to the absolute value of x. So this denominator, the square root of x squared, becomes an extra absolute value of x in our denominator of the denominator, which becomes the absolute value of 1 over x squared. And what we've got is we've got negatives that cancel out and 1 over x squareds that cancel out, which just leaves us 1 over the square root of 1 minus x squared, a common derivative that we will see later on in the course.